OWASP top 10. Well, these OWASP top 10 are changing every couple of years because new vulnerabilities are making their way to the front, usually based on technology and driven by new development standards for software and systems. However, that's why I don't want to zoom in and say this is the I don't know, this is the latest one, this is the previous one. So there is, let's say, there's this fact of OWASP.org has the top 10 vulnerabilities listed, and that's usually the standard of the penetration testers and security researchers to look for vulnerabilities, exploitable vulnerabilities. More importantly is to see what is over the years, what type of vulnerabilities have been always present. And therefore, here in the overview, it's a little bit more generalized, and if you count, it's not totally 10, because I grouped it together by meaning and by severity, and just try to give a glimpse of this. So broken access control is something that's very typical, has a lot of varieties how it appears. It could be weak credentials, weak encryption around credentials, weak authentication mechanism, missing multi-factor, bypassing some sessions authorizations, and even hijacking session management. So this is all, I mean, how to get into the application, or how to get further in by gaining more privileges. This is for me always something that is around access control, and if it doesn't work as intended, or it's even wrongly configured, so it's sometimes not really a vulnerability per se, but it's just bad design. Second one is more data related, but yeah, I mean, it applies also to encryption, but let's keep it here for data. In particular, missing encryption or lack of encryption or weak encryption. It could be even the encryption is fine, but the key management is not great. So therefore, there's a lot of things around data protection if you want to put it even more generic. However, the main issue is always everything should be encrypted: data in transit, data at rest, credentials, other sensitive information that is required to operate the application, like metadata and things like that. Then injections are not eliminated. Classic one was always SQL injections, but also, cross-site scripting is also a type of injection, because there is like code injected into the actual original code of the website, and depends on which way you exploit it. You can give it a different name, but at the end of the day, is the attacker can somewhere put code. Malicious code to be executed together with the website, and falsely taken by the user as legit. Then also a classic one, which you don't have to necessarily conduct a penetration test or something. Misconfigurations can be even reviewed statically on the server. So if you know what is a good configuration profile, you can see like standard passwords and all these kind of things. Can be seen as broken access control too, but I would say something that is very basic and essential, kind of a no-brainer thing, I would rather call misconfiguration, because this is literally reckless usage of a system or infrastructure, and therefore belongs into that category to be rectified very quickly. Usually doesn't even have much impact on the application, as long as it's not closing some ports may cause some disruption between different modules, but maybe it should have not been designed that way in the first place, because if a sensitive port has to be closed and it doesn't allow the application to operate, then it was a design flaw in the first place. So there must be a workaround for this. Outdated components, typical patching topic, but always forgotten. Not mentioning the end of life topic here, where components are so old and they have to be literally replaced by something better. A full upgrade has to be performed. but also minor patches, especially for known vulnerabilities or zero-day vulnerabilities. But also small components like software components. When you install some plugins and additional features, you have to keep an eye on it when there's a new version, when there was a bug fix, not only for the health of the application and proper maintenance, but also from a security point of view. There are security patches that are necessary to be performed, so you can prioritize there in case you have a bit of a resource constraint. For the coding part itself, depending on the coding language, you can refer to the OWASP cheat sheets, which are also on the same website together with the OWASP Top 10. I mean, by the way, OWASP Top 10, again, it's a selection out of many, many OWASP vulnerabilities listed there. I think there are like more than 700 in total, and only that the top 10 makes it to the top 10 doesn't mean there's not another 690 plus. Therefore, again, to emphasize good programming, and also instead of working issue by issue, there's a good approach to train the developers, or they can self-train using these cheat sheets, which for each programming language, let's say for Java or .NET, you can read up how to avoid the OWASP Top 10 and other common vulnerabilities occurring in the constellation of using this programming language. You can derive some secure coding guidelines out of it, or you can even use a code scanning tool to perform a validation, because they all refer to these OWASP standards as well. And you can then basically see if the OWASP cheat sheets that the developer has read before are adhered to, and the code is considered as vulnerability free, at least regarding top 10 or let's say other coding specific issues. CIS benchmarks is also something good to mention, because that is related to the server configuration. Normally not in the OWASP cheat sheets, because again, OWASP is more for the web application development point of view. CIS is more for the infrastructural point of view. How is it configured? What's the best practice, for example, for a Linux server in the cloud, or what's the best thing for a Microsoft SQL server? What should be switched off? What should be switched on? Of course, you always have to test your application after you do these kind of changes and hardening things, but at least it gives you some kind of a guideline. You can work point by point and see if something does not work. You just roll back and assess the risk if that specific configuration item should be still implemented, or you can take the risk. But again, awareness trainings are the key here. Again, my opinion on this: appeal always to the pride of workmanship of developers. Don't put it. I mean, of course, you have to. When you perform a security test and there's vulnerabilities, none of the developers is happy about it. But just say it, put it the way that it's an improvement of their craftsmanship of designing and building a system. Don't limit yourself necessarily to the OWASP Top 10. Make it OWASP Top 20, OWASP Top 30. It's not a big problem to have more insight, because again, it's all about good, secure system development and design. And of course, you can use tools for static application security like code reviews, interactive application security testing, which is like putting agents on your web servers and scanning that. Then there's also dynamic application security testing, and the normal penetration test. And if you realize that there's a lot of vulnerabilities and maybe you have a bit of a problem at the moment to change developer, or you need some more time to develop the developer to do good coding, you may want to opt to implement a web application firewall, which at least takes away a bit of the bad traffic. And if someone tries to do, for example, injections, which is one of the common ones, it will block that malicious attack, and you have some time to recover from it.